Hi everyone, this is Dr. G. Ravindranath Reddy, Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So we are discussing numerical methods and integral transform course. In that course, we are taking Laplace transforms. Now in this video, we will give the introduction to the Laplace transform. So what are the applications of Laplace transform? We are going to discuss now. So this Laplace transform is a mathematical tool, so which converts a function of t time domain to function in the frequency domain. Suppose if I have given a function f of t, so which is in time domain, so if you want to convert this into a function of frequency domain, that is f bar of s, then we can apply the Laplace transform here. So this Laplace transform is an integral transform. So this is possible. Converting of f of t into f bar of s is possible only by using integral transform, by using that integrals. So this Laplace transform is one of the integral transform which transform from one variable to another variable. So this has many applications in the science and technology. Now one by one we will discuss here. First we will see what is the purpose of studying this Laplace transform here. So the primary goal of this Laplace transform is simplify the analysis of dynamic systems by transforming differential equations into algebraic equations. So the main application of this one is, so we can solve the differential equations, we can convert these differential equations into algebraic equations, and then we can get our required solution for these differential equations here. So the main use of this Laplace transform is solving the differential equations or converting the differential equations into the algebraic equations here. So now we will see how this Laplace transform works. So it involves, so already we said that Laplace transform is an integral transform. This is the integration we have to use, integral 0 to infinity e power minus st into f of t dt. So by using this integral, we are converting the function f of t into the function in terms of s. So here s is represents the real or complex numbers, or this t represents the variable which is in a time domain. So and this integral 0 to infinity e power minus st into f of t dt. So this we will take the help of this integration and we will convert that function of f of t into the function of f bar of s. So here we have taken a domain, t domain here, so we can take the functions here f of t. Now if you apply the Laplace transform for this function, so it domains this converted into a codomain, that is s domain here. So that is f bar of s. So this Laplace transform transforms one variable into the another variable by taking the help of this integration. So now key concepts here, time domain, already we said that. So the original domain where the functions are expressed in terms of time. So this is our time domain. So that's why we have taken the function as f of t. So like example, voltage as a function of time in electrical circuits. So the time domain is the key concept here, and here we can consider the frequency domain, that is after converting this f of t into f bar of s, that is a frequency. So the domain to which the Laplace transform converts the function using the complex frequency, that is small s. So this is the codomain, we can call it as a frequency domain. So after applying this Laplace transform for the time domain function, it will be converted into a frequency domain. And one more important concept is inverse Laplace transform here. So the process of converting the function from s reverse, from frequency domain to, if you want to convert into a time domain, then we have to take the help of this inverse Laplace transform. So now we will take the applications to Laplace transform, where you can use these applications, where we can use this Laplace transform in the different branches of engineering. First we will concentrate on the electrical engineering. So we will take we will study this Laplace transform in the circuit analysis. So in the circuit analysis, this Laplace transforms are the fundamentals in analyzing electrical circuits, especially involving inductors and capacitors. So in order to solve these circuits here, we have to solve some differential equations. So wherever we have differential equations, in order to solve the differential equations, we can apply this Laplace transform technique here. So this is second one, transist analysis. So there are crucial for understanding the behavior of circuits during transist periods, such as when the circuit is switched off on or when there are sudden changes in the voltage or current. So whenever we are having this type of situations, here also we can use the concept of this Laplace transform. And whereas in the control systems, so this control systems, in the control systems, this Laplace transform plays an important role here to perform the activities of a robotics. So here, to analyze the stability and performance of the systems and to design the controllers that achieves desired system responses here. So in nowadays we are using this Laplace transform everywhere here, wherever we use the robotics. So robotics, we are using this robotics everywhere in all the fields of engineering, and even in the hospitals also, in the health sectors also we are using the robotics. So the purpose of robotics is endless. We have many uses of robotics. We are using in any field, we are using the robotics here. So in the study of the robotics arms, the movement of this robotic arms, we will study the concept of Laplace transforms also. So whereas when you come to this mechanical engineering, so we can use the concept of Laplace transform in the vibration analysis. So this Laplace transforms are used to analyze the vibrations in mechanical systems such as bridges, buildings and machineries. So they help to determine natural frequencies, damping characteristics and the system responses to external forces. So the Laplace transform is also used to study the vibrations of the bridges, buildings and machineries. So in this also we can use the concept of Laplace transform here. And it's already we said that we will use this Laplace transform technique in the robotics. So in the robotics, these Laplace transforms are used for the mathematical modeling of robotic arms and for designing the controllers that ensure movements and positions of that robotics. So in control system, so Laplace transforms are used to create the mathematical models of complex systems, representing their behavior in terms of transfer functions. So similarly, we can use in the stability analysis also. So these Laplace transforms are essential for determining the stability control systems, ensuring that they operate reliability and without oscillations or instability. So similarly, we can use in the controller design also. So in most of the cases, we can use these Laplace transforms. So we know the very important thing is robotics. So this robotics plays an important role in our daily life. So by using this robotics, we are using for many purposes. So this is a very important concept we will study. So other engineering fields, so we'll take not only for this engineering, this we can also in the physics also, in signals processing, nuclear physics, and even in the chemical engineering also we will use this Laplace transform techniques. So here we have discussed the Laplace transform applications where you can use this Laplace transform, and in the next class we will go for the properties of Laplace transforms.